portable refrigerator by NEXTECH Garage.
Hello everyone. This is update from NEXTECH Garage. Today I am excited to present smart solar powered refrigerator project. Let us check the components used in this project. We used Arduino UNO, 3 Peltier modules, MPPT charge controller, solar and battery system, DHT11 temperature monitoring, servo motor, TFT display, cooling fans, 5 volts buck converter. This refrigerator runs completely on solar energy. The solar panel charges a battery through an MPPT charge controller, which ensures efficient charging even under low sunlight conditions. The stored energy is then regulated using a 5-volt buck converter to provide stable power to the entire system. For cooling, we used 3 Peltier modules. The cold side of the Peltier modules faces inside the refrigerator, while the hot side faces outside. To remove heat from the hot side, cooling fans are installed. This improves heat dissipation and increases the cooling efficiency. To monitor the internal temperature, we used a DHT11 sensor. The real-time temperature is displayed on a TFT display mounted on the body of the refrigerator. One of the smart features of this project is the automatic door mechanism. When the push button is pressed, the servo motor opens the door. If the door is not closed within 10 seconds, it automatically closes. This prevents cooling loss and improves energy efficiency. The entire system is controlled using an Arduino UNO, which continuously monitors temperature, button input, and door timing. This project is ideal for rural areas, off-grid homes, and locations with frequent power cuts. It combines renewable energy with embedded systems to create an energy-efficient smart refrigeration system. Now let us check the circuit connections. This is the complete circuit of the solar-powered smart cooling system. First, the solar panel connects to the MPPT charge controller. The MPPT then connects to the 12-volt battery to safely charge it. From the battery, power is divided into 2 lines. One line goes to the buck converter, which steps down 12 volts to a stable 5 volts for the Arduino. The other line goes to the relay to control the Peltier modules. All grounds in the system must be common. The Arduino acts as the main controller. The DHT11 temperature sensor connects to 5 volts, ground, and digital pin 2. The TFT display connects using SPI pins. The servo motor connects to pin 6 for automatic door control. The push button connects to pin 4 using internal pull-up. The relay control pin connects to Arduino pin 7. 3 Peltier modules are connected in parallel. Their positives connect through the relay, and negatives connect to battery ground. Cooling fans are connected in parallel and run when the Peltiers are on. Always use proper heat sinks, thick wires for high current, common grounding, and correct battery polarity. This completes the system explanation. Thanks for watching.